Hello, my name's Mrs O'Neill and I work for the Athelston Trust Central team. I'm going to talk you through the November 2019 Higher Tier Paper 2. Have a go at the questions first if you can before you listen to my solution. If you need some help, maybe listen to the first little bit of my introduction to the question and then pause it again to see if you can get full marks on the rest of the question. Good luck! These sentences are on every paper right at the start. They say, answer all questions, write your answers in the spaces provided, and you must write down all the stages in your working. I'm not sure how many students actually read these 3 lines, but they are really important. Something I would thoroughly recommend is answering all questions. Unless you've written something, there's no way you can pick up any marks. And if you look through your question level analysis from your mocks, it's likely there are quite a few questions where you've picked up 0 marks, not because you got it wrong, but because you actually didn't write anything. Can I please thoroughly recommend that you try and attempt as many questions as you possibly can, writing something, even if you have to go back to them after you've finished the paper. Writing your answers in the spaces provided is really important because the paper gets scanned in for the examiner to mark, and therefore if you write outside of that area, they may miss your bit of working. And finally, writing down all the stages in your working means that you may get credit for your workings even if your final answer is incorrect. So if you type something into your calculator, make sure it's written down on the page as well. If you think something in your head and do a little bit of calculation in your head, write it down on the page as well. The examiner needs to see everything you've done. Now let's start the paper. Question 21. The table shows some information about the weights of 50 potatoes. Iveta drew this frequency polygon for the information in the table. The frequency polygon is not fully correct. Write down 2 things that are wrong with the frequency polygon. So we need to identify 2 things. There may be more, but we only need to write down 2 things. So there are actually 3 things that I can spot. Firstly, I'm looking at the y-axis and there is no label here. So up here we would need to write something about there being no label on the y-axis. Something else I've spotted is that the frequency polygon has been made into a polygon. So we have this first point and last point being joined. So we need to write something about that. So the first point and last point should not be joined. And finally, although we only need 2 things, there is a third thing you could have picked from. And that is looking at this first point again. Hopefully you look and see and read across that we're not actually at this frequency 6. They have plotted the incorrect first point, plotted first point incorrectly. It should be at 15.6, whereas it's been plotted at 15.8. Any one of those 3 or a variation on that wording, as you'll see below, will get you the marks. The length of a pencil is 128 millimetres correct to the nearest millimetre. Complete the error interval for the length of the pencil. So we know this number has been rounded, 128 millimetres. I'm going to put that in the middle of my number line. That's 128 millimetres, not 127 and not 129. So if I go halfway in between those values, I get 127.5 as the minimum it could be, including 127.5, that would round up to 128, and the maximum it could be up to would be 128.5 millimetres, but not including it. That's why you can see on the inequality that they've written on the answer line, it doesn't have the equal sign underneath. So the minimum it could be would be 127.5 millimetres, and the maximum it could be up to, but not including, would be 128.5 millimetres. Tom and Adam have a total of 240 stamps. The ratio of the number of Tom stamps to the number of Adam stamps is 3:7. Tom buys some stamps from Adam. The ratio of the number of Tom stamps to the number of Adam stamps is now 3:5. How many stamps does Tom buy from Adam? You must show all your working. So I know there are 240 stamps to start off with, and they are in the ratio initially Tom to Adam of 3 to 7. Tom buys some stamps from Adam, and the ratio becomes Tom to Adam 3 to 5. So initially there were 10 parts. 3 plus 7 equals 10 parts, and so each part would have been worth 240 divided by 10, which is 24. So each part was worth 24 stamps. Tom had 3 of those parts, so 3 times 24, which gives us 72. So originally Tom had 72 stamps. We could go on to work out how many Adam had as well, but we don't need to. Then once he'd bought some stamps, they were in the ratio 3 to 5, so 3 plus 5 gives us 8 parts. So still 240 stamps divided by 8, which is 30. So each part is now worth 30. Tom still had 3 parts, so 3 times 30. So Tom now has 90 stamps. It says, how many stamps does Tom buy from Adam? Well, he had 72 stamps and he's gone up to 90. So 90 take away 72 leaves us with 18. So Tom has bought 18 stamps from Adam. 18 is our answer. Each person in a fitness club is going to get a free gift. Stan is going to order the gifts. Stan takes a sample of 50 people in the fitness club. He asks each person to tell him the gift they would like. The table shows information about his results. 17 people wanted a sports bag, 7 people wanted a gym towel, 11 people wanted headphones, and 15 people wanted the voucher. There are 700 people in the fitness club. Work out how many sports bags Stan should order. So if we look at the sample, we know that there are 17 people out of the 50 that wanted the sports bag. That's 17 out of 50. Now, if there were only 50 people in the fitness club, then it would be obvious, hopefully, that Stan should order 17 sports bags. However, there are 700 people in the fitness club, so we need to scale this up. So if I multiply that by 700, that will tell me how many sports bags he should buy. If you put that into your calculator, you get 238. So 238 is the number of sports bags Stan should buy. Part 2, write down any assumption you made and explain how this could affect your answer. So in this one, you need to write down that it assumes a representative sample. Assumes the sample of 50 is representative of all members of the fitness club. Otherwise, if it's not, then the more or less sports bags would need to be ordered. So assumes the sample of 50 is representative of all members of the fitness club in order to make the numbers correct. Or the number of sports bag ordered correct. Sports bags ordered correct. There's a few different alternatives you could write in there, as you can see above. Here are 6 graphs. Write down the letter of the graph that could have the equation y equals x cubed and y equals 1 over x. Let's take each graph in turn to think about which one could be y equals x cubed. So graph A is a parabola. That's a quadratic graph, so its highest power of x will be 2. It's an x squared graph. B is a cubic graph, but it's not the graph of y equals x cubed because it crosses the x-axis 3 times, whereas for the graph of y equals x cubed, it will only cross once. C is a reciprocal graph. D is also a reciprocal graph. E is a linear graph, and F is a cubic graph, and it only crosses the x-axis once at the origin. 0 cubed is 0, and therefore F is the answer to A. For part B, y equals 1 over x, that's a reciprocal function, so we're looking for a reciprocal graph, and then we need to make sure it's a positive reciprocal graph, so we end up with D as our answer for part B. The nth term of a sequence is 2n squared take 1. The nth term of a different sequence is 40 take away n squared. Show that there is only one number that is in both of these sequences. So I think the best way to do this is to generate some terms of the sequence. I'm going to do that in a methodical way. I'm going to draw out a little table. I'm going to have my nth term of the sequence here. So 2n squared take 1 is the first sequence, and 40 take n squared is the second sequence. And then for the first term, n is 1. For the second term, n is 2. For the third term, n is 3. For the fourth term, n is 4. And for the fifth term, n is 5. So to generate the terms of the sequence, I'm just substituting in 1 for the first term. So 2 times 1 squared, 2 times 1 is 2, take away 1 is 1. 2 times 2 squared is 8, take away 1 is 7. 2 times 3 squared is 18, take away 1 is 17. 2 times 4 squared is 32, take away 1 is 31. 2 times 5 squared is 50, take away 1 is 49. I'm going to stop there and I'm going to do the next sequence. If I need to do some more terms, I will. So 40 take away n squared. So the first one, 40 take away 1 squared is 39. 40 take away 2 squared is 36. 40 take away 3 squared is 31. 40 take away 4 squared is 24. And 40 take away 5 squared is 15. At this point then we can see that we have one number that is the same in the sequence. So 31 is in both sequences. We don't need to carry on because we can see that the first sequence is increasing and the second sequence is decreasing. Therefore, we're not going to have another number that's in both sequences. Work out 3.42 times 10 to the negative 7 divided by 7.5 times 10 to the negative 6. Give your answer in standard form. So when we're looking at this one on a calculator paper, ideally you would type this into your calculator. So if you type in 3.42 and then use the button that says times 10 to the x or exp, press that and then type negative 7 in, then divided by 7.5, use the times 10 to the x button again, and then negative 6, press equals, and you will get the answer 0.0456 come up on your answer screen. Now it does say give your answer in standard form. That's not written in standard form. To be written in standard form, it has to be a number between 1 and 10, including 1 but not including 10, times 10 to the power of something. So I'm going to write it as 4.56, that's a number between 1 and 10, that I can then multiply by 10 to the power of something to get back down to 0.0456. Now, because it's less than 1, I know I'm going to have a negative power. It's moved all the numbers 2 places smaller than I actually have written here. So 4.56 has become 0.0456. So I need to move everything 2 places smaller, and therefore it becomes 4.56 times 10 to the negative 2. If you want to check it, or you're not sure on how to use the times 10 to the x button on your calculator, then you could write it as 3.42 divided by 7.5, do that in your calculator, times 10 to the negative 7 divided by 10 to the negative 6. If you put 3.42 divided by 7.5 into your calculator, you get 0.456, and that's being multiplied by 10 to the minus 1, or 0.1, which is the same as 0.0456. You could use your index laws on here as well. 10 to the negative 7 divided by 10 to the negative 6 is the same as negative 7 take away negative 6, which leaves you with negative 1. So we've got 10 to the negative 1 there. The answer should be 4.56 times 10 to the negative 2, however you get there. The number of days, D, that it will take to build a house is given by D equals 720 divided by N, where N is the number of workers used each day. Ali's company will take 40 days to build the house. Haley's company will take 30 days to build the house. Haley's company will have to use more workers each day than Ali's company. How many more? So the number of workers used each day is represented by N, and the number of days it takes to build the house is represented by D. We know that Ali's company, D, the number of days, is equal to 40, and for Haley's company, the number of days is 30. So if we substitute that into the equation that we've been given, so we get D equals 720 divided by N, so therefore 40 equals 720 divided by N. So 40N equals 720, so N is equal to 720 divided by 40. 720 divided by 40 is 18, so 18 workers for Ali's company. Haley is quicker though, she takes 30 days, her company takes 30 days, so 30 equals 720 divided by N. 30N therefore is equal to 720, and N is equal to 720 divided by 30. So N, the number of workers for Haley's company, is equal to 24. So we now know that Ali's company uses 18 workers, Haley's company uses 24 workers, so 24 take away 18 is 6 workers. Haley's company uses 6 more workers than Ali's company. The diagram shows a cube and a cuboid. The total surface area of the cube is equal to the total surface area of the cuboid. Janet says the volume of the cube is equal to the volume of the cuboid. Is Janet correct? You must show how you get your answer. So we know that the surface area of the cube is equal to the total surface area of the cuboid. They've told us that. We're then checking to see whether Janet's statement about the volume being equal is correct. So let's start with the surface area first of all. So the surface area of the cuboid we can work out by finding the area of those 6 rectangular faces. So I'm going to label them the ends. So we've got 2 ends, we've got 2 sides, and we've got a top and bottom. So the ends, first of all, they're 6 by 8, but there's 2 of them, so I need to times by 2. The sides, they're 6 by 18, but there's 2 of them, so I need to times by 2. And the top and the bottom, well, they are 8 by 18, but there's 2 of them. So if I then work out what they are on my calculator, 6 times 8 times 2 is 96. 6 times 18 times 2 is 216, and 8 times 18 times 2 is 288. Right at the beginning of the paper I said anything you put into your calculator make sure you write out as well. So we've typed in 6 times 8 times 2 into your calculator, make sure you've written it down on your paper as well. I'm going to add those up then to give me the total surface area, which gives me 600 centimetres squared as a surface area. Then I can take the fact that I know that the surface area of the cube is equal to the total surface area of the cuboid. Now I'm going to label the side length of my cube as x. So all the sides are the same because it's a cube, so they're all labelled x. So when I want to find the surface area of this, I've got this square here, but there's 6 of them, they're all the same shape, so the area of one face would be x squared, but I've got 6 of them, so that's 6x squared. And I know, because it tells me in the question, that that must be equal to 600 because it's the same as the surface area of the cuboid. So if 6x squared is equal to 600, if I divide both sides by 6, I get x squared must be equal to 100. Now I need to find the square root of that to find x on its own. So the square root of 100 is x. So x must be equal to 10. It can only be positive because it's a length. So 10 centimetres is the length of x. I'm then going to use that information to help me with the volume. So the volume of the cube then, I find by doing 10 times 10 times 10, or 10 cubed, and that gives me 1,000 centimetres cubed. The volume of the cuboid is going to be 6 times 8 times 18, and if you type that into your calculator, you get 864 centimetres cubed. So I now need to finish the question. It says, is Janet correct? Janet is incorrect, or Janet is not correct. We can clearly see from our workings the volume of the cube is 1,000 centimetres cubed, and the volume of the cuboid is 864 centimetres cubed. Number 10. Make k the subject of the formula y equals the square root of 2m take k. So where it says make k the subject of the formula, it means that we want k on one side and everything else on the other side of the equal sign. At the moment, y is the subject. So if we're going to rearrange this, we need to make sure we do opposite or inverse operations. So we've got y equals the square root of 2m subtract k at the moment. The first thing I'm going to do then is think about what happens going forward. So at the moment I've got 2 times the m value, I take away k and I get the square, and then square root that, I get y. The first thing I'm going to do is to unpick this by getting rid of the square root sign, and in order to do that I need to square both sides. So if I square both sides, I get y squared equals 2m take away k. So then I'm going to add k to both sides to make it positive. So I get y squared plus k on this side, and I get 2m on this side because a negative k, add k is 0. I then want to get k on its own, so on this side I've got y squared plus k. So if I take away the y squared from both sides to keep it balanced, I end up with k on this side, and if I take away with y squared from this side, I end up with 2m take y squared. So the answer for 2 marks is k is equal to 2m subtract y squared. Question 11. Megan grows potatoes. The box plot below shows information about the weights of Megan's potatoes. Megan says that half of her potatoes weigh less than 50 grams each. Part A, is Megan correct? Give a reason for your answer. So if we look at the box plot, we've got these whiskers coming down, so we've got a minimum at 23, we've got a maximum at 72, and then we've got our lower quartile at 39, our median here at 57, and our upper quartile at 65. Now, the one we're interested in then is the median at 57, because the median is the midpoint of the data. It means that half her potatoes weigh less than 57 grams, not 50 grams. Therefore, Megan is incorrect. No, she's not correct. The median is 57 grams. Amy also grows potatoes. The box plot below shows information about the weights of Amy's potatoes. Compare the distribution of the weights of Megan's potatoes with the distribution of the weights of Amy's potatoes. So when they ask these questions, they're looking for 2 things for you to compare. They're looking for you to compare the median, the type of average, and the spread of the data using either the interquartile range or the range. So 2 marks for this question. First thing I'm going to do is look at the medians. We can clearly see the median for Megan, which we've already talked about, is 57 grams. And the median here for Amy is 42 grams. So first thing we can say is that on average, using the median, Megan's potatoes weighed more. That will give me 1 mark. And then the second thing I need to do is compare the spread of the data. I'm going to look at the interquartile ranges. We can clearly see that the interquartile range for Amy, this bit here, is smaller than it is for Megan. So the data is less spread out, or we could say more consistent using the interquartile range. The data is less spread out for Amy. Her interquartile range is smaller, so the weight of her potatoes are more consistent. Number 12. The diagram shows triangle ABC. ADC and DEB are straight lines. AD is 4.4 centimetres, BC is 8.6 centimetres, E is the midpoint of DB, so I can put little lines on there and there to show that they're the same length. And then angle CDB is 90 degrees, and that means that angle must also be 90 degrees at ADB. And angle DCB is 40 degrees, shown on the diagram. Work out the size of angle EAD. So EAD creates that angle there. Give your answer to one decimal place. That's important for that final answer mark. You must show all your working. So I'm going to start this by taking triangle BDC, which looks like that. And I know that this is 40 degrees, and I know that this is 8.6 centimetres, and I want to work out this side BD. And once I've worked that out, and I can halve it, I can work out ED, and that will then give me another side in triangle AED in order for me to use SOHCAHTOA to work out angle EAD as they've requested. So first of all, then I need to find this side length BD. So I'm looking for this missing side here. And so therefore I am going to use sine. So sine of 40 is equal to the opposite. Don't know what that is. I'm going to call it BD divided by the hypotenuse, which is 8.6. Right. So then in order to work out what BD is, I need to do 8.6 times sine 40, that will give me BD. If I put that into my calculator, I get 5.52797, and it keeps on going. I'm going to leave that in my calculator. Don't press clear, leave that in your calculator. It says to give your answer to one decimal place. When we're doing our workings, we want to work to a higher degree of accuracy than that. Leave that in your calculator then, and I want to now work out what ED is. So in order to do that, I need to halve it. So ED is a half of BD. So if I do half times my answer that's in the calculator, I think I get 2.76399. I'm going to leave that in my calculator still. Don't press clear. Show all your workings. So we've now got another side in triangle AED. I've got this triangle here. I've got a right angle there. I now know this side length, ED, is 2.76399 to 5 decimal places. And they already told me this angle, this side length was 4.4 centimetres, and I'm trying to work out this angle here. I'm going to call it X. So if I want to work that one out, I've got the opposite and the adjacent, so I'm going to use tan. So tan of X is equal to the opposite, 2.76399, but that's still in the calculator. Leave it there, divided by 4.4. So therefore, to find the angle X, I'm going to use inverse tan of 2.76399 divided by 4.4. So in your calculator, shift tan, fraction button, we'll use divide, answer divided by 4.4. And then when you put that into your calculator,
and press equals, you should end up with an answer that rounds to 1 decimal place to 32.1 degrees. Question 13. Sakira invested £3,550 in a savings account for 3 years. She was paid 2.6% per annum compound interest for each of the first 2 years. She was paid R% interest for the 3rd year. Sakira had £3,819.21 in her savings account at the end of 3 years. Work out the value of R. Give your answer correct to 1 decimal place. So Sakira started with £3,550. I'd like, first of all, to work out how much she had at the end of those 2 years. So I need to change this 2.6% into a multiplier. As a decimal, 2.6% is 0.026. So I'm going to multiply by 1.026. If I multiply by 1, it would keep it unchanged. The extra 0.026 means that I get that extra 2.6% added on. But then that happens again because it's in the 1st year and the 2nd year. So I would multiply by 1.026 again. So instead of doing that, I can write times squared. And then for the 3rd year, it gets multiplied by another multiplier, but I don't know what that is. It says R% interest. So I'm just going to call it A, an amount. And that I know then is equal to £3,819.21. So if I calculate in my calculator 3,550 times 1.026 squared, I end up with £3,737. It did come up with 3,736.9998 on my calculator. So given that we're working with money, I need to round it to 3,737, and that's still being multiplied by the A, and that gives me £3,819.21. So to work out A, this amount, I'm going to divide both sides by 3,737. And when I do that in my calculator, I get the amount as 1.02199989, which if I round it gives me 1.022. Now I'm interested in this R% interest that they asked me because that's the value I need to give, and I need to give it to 1 decimal place. So if we think about this then as a multiplier, what would the interest rate be? Well, the 1 would keep it unchanged, so I'd have the same amount. This extra 0.022 as a decimal, we've got 0.022. As a percentage, we would have 2.2%. So the value of R is 2.2. Question 14. Sadia is going to buy a new car. For the car, she can choose 1 body colour, 1 roof colour and 1 wheel type. She can choose from 19 different body colours, 25 different wheel types. The total number of ways Sadia can choose the body colour and the roof colour and the wheel type is 3,325. Work out the number of different roof colours that Sadia can choose from. So I know that the 19 is the different number of body colours, and if I multiply that by the number of different wheel types, 25, and I multiply that by the number of different roof colours, don't know what that, I'm going to call it R, then I get 3,325. Therefore, 475 R is equal to 3,325. So R is equal to 3,325 divided by 475. R must be equal to 7. 7 roof types, different colours of roof. Question 15. Expand and simplify 3x plus 2 multiplied by 2x plus 1 multiplied by x take 5. So for this one, we need to multiply out these first 2 brackets first of all. So we're going to expand those brackets, and I'm going to do it in a table so that I don't forget anything. You may have been taught a different way, that's fine. If you've got your method, you can use that. So we've got 3x plus 2 times by 2x plus 1. And if I expand those brackets, I then do 2x times 3x, which gives me 6x squared, 2x times 2, which is 4x, 3x times 1, which is 3x, and 1 times 2, which is 2. And then I'm going to simplify that by collecting like terms. So I'm going to collect the x terms together, and I get 6x squared plus 7x plus 2. And then I'm going to multiply that by x take 5. So I now need to expand these two brackets, and I'm going to do that in another grid. So I'm going to put 6x squared, the 7x, and the 2 on the top, and then x and negative 5 down the side. Now I won't forget to multiply any terms together. So I've got x times 6x squared gives me 6x cubed. 7x times x is 7x squared. X times 2 is 2x. And then we've got negative 5 times 6x squared, that's negative 30x squared. Negative 5 times 7, that's negative 35x. And negative 5 times 2 is negative 10. And now I need to simplify it. So there's only one x cubed term, so I can put that there straight away, 6x cubed. And then 7x squared, add negative 30x squared is negative 23x squared. And then the x terms, 2x add negative 35x, or negative 35x add 2x is negative 33x. And finally, the constant on the end, minus 10. Question 16. Marek has 9 cards. There is a number on each card. Marek takes at random 2 of the cards. He works out the product of the numbers on the 2 cards. Work out the probability that the product is an even number. So product, we're going to multiply. So when he's working out the product, he's multiplying the 2 numbers together. And we want to know the probability that it's an even number when we get the product. So I think the easiest way to deal with this is to do a probability tree diagram. So we want to know whether the number is even or the number is odd. So when he takes his first card, there are 9 cards and 4 of those are even. And if he were to take an odd card, 5 of them are odd and there are 9 cards. So the probability of an even number is 4/9 and the probability of an odd number is 5/9. Then once he's already picked a card, there's 1 less card. So for the second pick, it's only out of 8. And if you already picked an even number, then there's 1 less even number. But if you picked an even number first time, then there's still 5 odd numbers in the pack. If, however, he picked an odd number the first time, there's still 4 even numbers, but there's 1 less card. And if he picked an odd number the first time, there's now only 4 odd numbers and 1 less card, so 4/8. Now, we want to know the probability the product is an even number. So an even times an even, that would give us an even. An even times an odd, that would also give us an even. An odd times an even, that would give us an even. But an odd times an odd would give us an odd answer. So what we're looking for is the probability of him getting an even and then an even, or an even then an odd, or an odd then an even. The quickest way to do this is to do 1 minus the probability that he picks odd followed by odd. So I'm going to calculate the probability of odd followed by odd. That's 5/9 times 4/8. And if you put that into your calculator, it'll come out in its simplest form as 5/18. You don't need a calculator for this, but if you put it into your calculator, you'll get that. And then we need to work out what 1 minus 5/18 is, because that's the probability of any of the other 3 outcomes happening. So that, I think, is 13/18. So the answer is 13 13/18. The probability the product is an even number is 13/18. Question 17. A and B are points on a circle with centre O. CAD is the tangent to the circle at A. BOD is a straight line. Angle ODA is equal to 32 degrees. Work out the size of angle CAB. You must show all your working. So angle CAB, let's identify that first of all. That's this angle here, coming round to the tangent. Some facts that I know that the tangent meets the radius, and this is the radius, this is also the radius, at 90 degrees. So I know there's a right angle in there, which means this must also be a right angle. And I also know then that I've got an isosceles triangle because I've got the radii here, OB and OA. So triangle OAD has 180 degrees in it. So I know then that this angle here, 180 take 90 take 32, must be 58 degrees. If that's 58 degrees, angles in a straight line add up to 180 degrees. So this must be 122 degrees in here. Because it's an isosceles triangle, then I need to do 180, take away the 122, and share that between the two angles here and here. So I think that leaves me with 29 degrees for each of those. So if they're each 29 degrees, then if I do 90, take away the 29 degrees, I end up with 61 degrees. So 61 degrees is my answer. It says I must show all my workings. The annotation on the circle is sufficient, so make sure you put all of that on there. You'll get 0 marks if you just write 61 degrees with no other workings or annotations. Question 18. The histogram gives information about the heights in meters of the trees in a park. The histogram is incomplete. 20% of the trees in the park have a height between 10 meters and 12.5 meters. None of the trees in the park have a height greater than 25 meters. Complete the histogram. So we need to use the information we've got already using these bars to help us work out how many trees we've already got there, and that will help us work out the total number of trees and therefore the height of the bar needed between 10 and 12.5 meters. So if we start off then, I'm going to do a little table. So if we know then that 0 to 2.5, that bar is 1.2 high. That's the frequency density, and I times that by the group width, which is 2.5, I get a frequency of 3. Then the next group, 2.5 to 5, that has a height of 2, and I multiply that by the group width, which again is 2.5, so that gives me a frequency of 5. The next one, 5 to 10, that's a height of 2.8, the frequency density is 2.8, and that has a group width of 5 this time, so therefore I get frequency of 14. The next one then is the one I don't know, so 10 to 12.5, I don't know that one, so I'm going to put this as X, my frequency of X, I don't know what that is, and then 12.5 to 25, I know has a height of 0.8 and a width of 12.5. So if I multiply those together, I get a frequency of 10. So my total frequency, therefore, is 32 plus X. Don't know what that is. So my number of trees times 0.8, because it said 20% of the trees in the park have a height between 10 meters and 12.5 meters. Therefore, there must be 80% for all the other heights of trees. So is equal to 32. And so the number of trees is 32 divided by 0.8, and that will give me 40. So I think there's 40 trees in the park, and therefore if I think about what's left, then the bit between 10 and 12.5 must represent 8 trees, so 40 take away 32 is equal to 8 trees. So now I need to work out the frequency density for that group. Frequency density is frequency divided by group width, which is 2.5 in this case, which gives me 3.2 as my frequency density. So when I want to draw my bar in, and I'm sure yours will be a lot neater than mine, I need to go up to 3.2 across and down, and you use a ruler, and that will get you the marks for showing that the height of the bar should be 3.2 and popping it onto your diagram. Don't worry about shading it in. That will just take up time that you want to use on questions elsewhere. Question 19. The diagram shows a hemisphere with a diameter 8.4 centimetres. Work out the volume of the hemisphere. Give your answer correct to 3 significant figures. So the volume of the hemisphere is half the volume of the sphere. So if the volume of the sphere is 4/3 pi r cubed, we then need to divide that by 2 to get the volume of the hemisphere. So 4/3 times pi times the radius cubed. So if the diameter is 8.4 centimetres, the radius then is going to be 4.2 centimetres. So we're going to multiply by 4.2 cubed, and then we need to divide all of that by 2. So alternatively, you could have put 2/3 times pi times 4.2 cubed and not worried about the dividing by 2 because you've done it at the start, or you can put that into your calculators, and then it says give your answer correct to 3 significant figures. So I think the answer is 155 centimetres cubed. Question 20. D equals 1/8 of C cubed. C is equal to 10.9, correct to 3 significant figures. By considering bounds, work out the value of D to a suitable degree of accuracy. Give a reason for your answer. So we know that C has been rounded to 3 significant figures. So if we think about C as 10.9, that's to 3 significant figures. That's 10.9. It's not 10.8, which would be the one it would round to below for 3 significant figures, and it's not 11.0. Therefore, in between there, the lower bound would be 10.85, and the upper bound would be 10.95. Okay, so the minimum value that C could take is 10.85, and the maximum value that C could take would be 10.95. So the lower bound for D is D equals 1/8 of 10.85 cubed, and that is 159.661 rounded. And the upper bound for D is therefore 1/8 times 10.95 cubed, which gives you 164.16 rounded. And then we're looking for D to a suitable degree of accuracy. So we've got 2 different values here, but I need a value that they both round to. So I think they both round to 160, and they both round to 160 to 2 significant figures. So 160 would be my answer, and the reason would be that they round to that to 2 significant figures, both of them. 22. The number of rabbits on a farm at the end of month N is Pn. The number of rabbits at the end of the next month is given by Pn plus 1 equals 1.2 Pn take 50. At the end of March, there are 200 rabbits on the farm. Part A, work out how many rabbits there will be on the farm at the end of June. So we've got the value for the end of March, there's 200 rabbits, and if we put that into replace Pn, we'll end up with the next month, so at the end of April, we will know how many rabbits there are. So if we know at the end of March, there is 200, then at the end of April, the next month, then there will be 1.2 times 200, take away 50 rabbits, and that, if you put that into your calculator, gives you 190. And then for the next month then, at the end of May, we do 1.2 times 190, take 50, and that gives us 178. And then finally, for the end of June, we do 1.2 times 178, take away 50, and that gives us 163.6. Now, we can't have 163.6 rabbits, so you need to decide you're going to write 163 or 164. Either would be fine in the mark scheme. I'm going to go for 163 because we don't yet have 164 rabbits. Although if you've written 164, that would be fine. That would round up to 164, wouldn't it? Part B. Considering your results in Part A, suggest what will happen to the number of rabbits on the farm after a long time. So we can see, as we go through the months, the population is declining. It's gone from 200 to 190, 178 to 163.6. So it's population declining. There are fewer rabbits. It's only worth 1 mark. Question 21. Here is a speed time graph for a train journey between 2 stations. The journey took 100 seconds. Part A. Calculate the time taken by the train to travel half the distance between the 2 stations. You must show all your working. So I know that the distance is the area underneath a speed time graph. So if I split up this area underneath the graph into 2 triangles and a rectangle, then I can work out the area, and that will tell me the total distance that they travelled. I then can work out half the distance and then go on to try and find the time taken. So let's split this into A, B, and C. So for part A, I know that it is 30 wide by 12 tall. Careful, read the scale. It's 10 here, up to 15, so that's 12. And then I've got to halve it. So that gives me a distance of 180 metres. The rectangle then in B, that's 50 wide by a height of 12. So that gives me 600 metres. And part C, that is 20 wide by a height of 12, but it's a triangle, so I need to halve it. So that gives me 120 metres. I then need to add those up. That gives me a total of 900 metres. So I've travelled 900 metres. I want half the distance, so 900 divided by 2, that's 450 metres. So I want to know how long it took to travel 450 metres. Well, I know in that first 30 seconds, the train travelled 180 metres. So if I do 450, take away that 180 from triangle A, that leaves me with 270 metres. So then I need to know how far into this bit, into rectangle B, I need to go in order to travel 270 metres. So I know a time times by 12, the height of the rectangle, is 270. So if I do 270 divided by 12, then I get 22.5 seconds. Then if I add on the 30 seconds from part A, 30 plus 22.5, that gives me a total time of 52.5 seconds. So 52.5 seconds is the length of time taken to travel half the distance between the stations. Part B, compare the acceleration of the train during the first part of its journey with the acceleration of the train during the last part of its journey. So the acceleration is looking at really the gradient of the lines. So in that first part of the journey, we have a positive gradient, therefore it's speeding up. And in the last part of the journey, it's a negative gradient, therefore it's slowing down. So we could write something like acceleration is positive in the first part of the journey and negative in the last part. You could also have talked about the steepness of those lines. So we can see that in the last part of the journey, the gradient of that line is steeper than the first part of the journey. Therefore, acceleration is greater in the last part of the journey than the first part. That would also be fine. Question 23. The diagram shows a parallelogram. The area of the parallelogram is greater than 15 centimetres squared. Show that 2x squared, take away 21x, add 40 is less than 0. So to find the area of this parallelogram, I need a perpendicular height. So I need this length here. So that creates a right angle there. Now that also creates a right angle here, meaning that I know that angle is 60 degrees. I can use that information then and SOHCAHTOA to work out this height. I'm going to call that h, the perpendicular height. So that is adjacent to the angle 60, and I've got the hypotenuse, so I'm going to use cos. So cos 60 is equal to the height divided by 10 minus x. Now I know cos 60 is a half, so cos 60 is a half, half equals h over 10 minus x. And then I want h on its own, so I'm going to multiply both sides by 10 minus x, and I get 10 minus x over 2 is equal to h. And now I have a height in terms of x. I can find the area of this parallelogram in terms of x. So that will be the height, 10 minus x over 2 multiplied by the length, which was 2x take 1. And that, they tell me, has to be greater than 15 centimetres squared. So that's greater than 15. So now if I expand this and rearrange, so I've got 0 on one side of the inequality, I should end up with what they have given me in the show that question, show that 2x squared take away 21x plus 40 is less than 0. So I just need step by step to do that now. So first thing I'm going to do is multiply through by 2 to get rid of the fraction. So I've got 10 take x times by 2x take 1. That has to be greater than 30. And then I'm going to expand these brackets, and I end up with 20x minus 10 minus 2x squared plus x is greater than 30. So if I collect those together, I get negative 2x squared plus 21x minus 10 is greater than 30. And then I need to get everything onto one side. So I'm going to make the x squared term positive. So I'm going to put a 0 here and add the 2x squared onto the other side. I'm going to take away the 21x from both sides, and I'm going to add 10 to both sides. And 10. And we end up with what they have asked for in part A. I've shown it. I've got them on the other side of the inequality sign, but because of the way round I've got my inequality sign, that means the same thing, so we can leave it like that, and that's fine. That's 3 marks. Part B says, find the range of possible values of x. So I've got this inequality, 2x squared, take away 21x plus 40 is less than 0. So I need to find some values now for x which satisfy this. So when it's equal to 0, so that will help me. So I factorise it. I end up with 2x at the start of that bracket and x at the start of the second bracket. I need numbers that multiply together to give 40, but when I add them together, and I will get 2 lots of whatever numbers here, they need to add together to get negative 21. So I think the values I need are negative 8 in here, because that will give me negative 16x, and then a negative 5 in there, because then that'll take me down to negative 21x, and they multiply to get positive 40. So my values that I'm interested in then, if I think about this as a graph, and where does it cross the axis? Well, it's going to cross at x equals 8, and it's going to cross at 5 over 2. When x equals 5 over 2, that bracket is equal to 0. So if I were to sketch the graph of y equals 2x squared, take 21x plus 40, it would go through those 2 points. I'm sure yours will be better than mine, so make that 8. And then I also know it would intercept at 40 there, but that's by the by. So the bit I'm interested in is where it's less than 0. So the bit I'm interested in is this bit under the line here, so where y is less than 0, and therefore my inequality will be one inequality. I'll have 5 over 2 here, and x has to be greater than that, but less than 8. And that's worth 3 marks as well, so 6 marks for that question. Question 24. Square ABCD is transformed by a combined transformation of a reflection in the line x equals -1, followed by a rotation. Under the combined transformation, 2 vertices of the square ABCD are invariant. Describe fully one possible rotation. So we've got a combined transformation, that's important, and means we're going to do 2 back to back. So then we have a reflection to start off with of the line x equals -1, and we're going to follow that by a rotation. Another important bit is then after we've done that final rotation, we end up with 2 vertices, so 2 corners of the square, which are invariant. And invariant means they haven't moved, so they're back where they started originally after the 2 transformations, the combined transformations. So we need to describe fully one possible rotation. So the first thing we need to do then is find out where this square goes to when we reflect it in the line x equals -1. So let's find the line x equals -1, and you're going to use a ruler to do this, but my line x equals -1 comes down here, that's x equals -1. And then if I reflect that square in this line, A is 2 squares away, so let's go do 2 squares the other side, and we can then draw in the rest of the square. I'm going to say that's A dashed in the image after we have reflected the object, B dashed, that's going to be C dashed, and then that's D dash. Okay, so I've done that first transformation, and then I need some tracing paper, and when I put the tracing paper on top, I can then rotate it round from different centres and different angles to try and get it so that I get either A, B, C or D, 2 of those points back onto the original square where they were originally so that they become invariant points. So I think one of the centres of enlargement that you could use, and there are more than this, is rotation about -1, 0. So -1, 0 here. If I rotate about this point here and I do it 90 degrees clockwise, then I end up with 2 invariant points. B and D are back on to the original vertices that they were on the original ABCD square. Question 25. The straight line L has equation 3x plus 2y equals 17. Now, there's quite a lot here to unpick, so we're going to go through step by step. Ultimately, we've got to find the area of triangle ABC. So the point A has coordinates 0, 2. So that's a start. We can put that onto a set of axes. We've got the point 0, 2. So 0, 2 is there. Okay. Then we need 3 other points for this triangle, and point B is line L crosses the y-axis at point B, and lines L and M intersect at the point C. So if I can find the y-axis intercept of line L, then I've got my point B, and also I know that the straight line M is perpendicular to L, so if I find the gradient of L, I can also find the gradient of M, and that will help me. Point A has coordinates 0, 2, so that will help me find the equation of the line M, because I know it passes through A. So let's start with line L. It's 3x plus 2y equals 17. If I rewrite that in the form y equals mx plus c, I get y equals 17, take away the 3x, that would leave me with 2y, and now I'm going to divide through by 2 to get 1y on its own. So that's the equation of line L in the form y equals mx plus c. That means the gradient of that line is -3/2. and the y-intercept is 17/2 or 8.5. Okay, so that then tells me that the y-intercept is 8.5, and it says line L crosses the y-axis at point B. So I now know point B, another vertex of my triangle, and I can put that on at 8.5. And then I just need point C, and that's where lines L and M intersect. So for M, then, I know the gradient is the negative reciprocal of the gradient of L, because it says M is perpendicular to line L. So the gradient must be the negative reciprocal of -3/2, so that would be 2/3. So I've got y equals 2/3 x, and then I need where it crosses the y-axis, my y-intercept, but it tells me that it passes through A, and A has coordinates of 0, 2. So that must be +2 on the end there. Okay, so I've now got the equation of two lines, and I need to find this point C, and that's where they intersect. So if I put them equal to each other, because they're both equal to y, I can have 17/2 take 3/2x, that's line L. That must equal 2/3 x plus 2. That's line M. So if I add 3/2x to both sides and take away 2 from both sides, I end up with 13/2 on this side, and on this side I get 13/6x. So all I've done is 2/3 plus 3/2. And that gives me the 13/6. And now I need to divide through by 13/6 to leave me with 1x. So you can do that on your calculator, or 13/2 times 6/13, which will leave me with 3. So x is 3, that's the x-coordinate of point C. So the x-coordinate of point C is 3. And then I need to know the y-coordinate, so y equals, and if I substitute it back into either L or M, so y equals, let's substitute it back into M, 2/3 of x, which is 3, plus 2, that leaves me with 4. So I now know the coordinates of point C are 3, 4. So I can put point C in now, that's 3, 4, so somewhere there, say, so that would be 4. So now I have my triangle. Now I need to find the area of that triangle, and I know this height here must be 3, and I know the distance here is 6.5. So if I do half, so I've got A equals 1/2 times the 3 times the 6.5, and if I put that into my calculator, I get 9.75, and so the area of the triangle is 9.75.